So this video is going to address the most missed questions from Exam 1, Part 1 for Summer 1 of 2025. I started leaving feedback on individual questions, and I noticed that I was leaving the same feedback over and over again. And so it just became more efficient to pull out all of the most missed or the most frequently missed questions and do it this way. These are not necessarily in the same order that they appeared in on the exam. They got a little mixed up when I was copying and pasting pictures, but it'll be fine. The first question I pulled deals with the lower class boundary. Now, there seems to be a big disconnect when it comes to the vocabulary for frequency distribution tables. We have two things that are getting confused. We have a limit and a boundary. A limit is the numbers you already see. This is the minimum and the maximum for the class. All of the ones on the left are the lower limits. All of the ones on the right are the upper limits. That tells you how low and how high you can go and still be within the class. Boundaries are totally different. The class boundary slides right in here. The class boundary, in this case, would be midway between 161 and 162. Because this is on the top end or the higher end, numerically speaking, for the first class, this would be the upper class boundary for the first class. In this case, we want the lower class boundary for the first class. So to find the lower class boundary, I don't want to be on the top end. I want to be up here on the bottom end. Well, Ms. Graham, there's not something up there for it to be in between. We'll make a class there. Your classes, skip 161 to 162, 163 to 164. So take the pattern backwards. If we continue that pattern, we would go from 158 to 159. And the lower class boundary for our first class is going to be midway between 159 and 160. Now you've got some options. If you're a formula person, you find the average. So we would average 159 and 160. You could put that in the calculator. 159 plus 160 divided by 2. Easy enough. Or, if you know it's only one jump from 59 to 60, and the middle would be 0.5, you can go straight to finding the lower class limit of 159.5. So this is the lower, I think I said that wrong, the lower class boundary. So the lower class boundary for the first class is 159.5. This time, we have the same table about fish. Different numbers, same idea. This time, we're looking for class width. Y'all don't think too hard on this one. The class width is the distance from one lower limit to the next lower limit. So this would be 103 minus 100. So your class width is 3. Miss Graham, what if I don't like 103? What if I have a thing about not using numbers with 3 in them? Okay, go pick another one. You could use 115 and 112. You get the same class width. So to get class width, you subtract consecutive lower limits. For the stem and leaf plot, we're looking at house prices over the last week. What was the most expensive house sold? Most expensive means we're looking for the max value. So, we need to look and see what our table's giving us. We have a stem in hundred thousands. So that means once I pick my stem, I'm going to multiply by 100,000. Well, the maximum is going to occur at my largest stem. My largest stem is 3. So I'm going to have 3 times 100,000. My largest leaf is what I want to get the largest number total. And my stem and leaf plot tells me that my leaves are in 10,000s. So I'll have 6 times 10,000. Now at this point, if you really stink at mental math, this is not the time to be a hero and try to do it in your head. Go use the calculator. That's what it's there for. I frequently use the calculator in front of my students for face-to-face classes. I'm totally not embarrassed to admit that I stink at mental math. This particular one I can handle because I'm slightly caffeinated this morning. We get 300,000 plus 60,000. So our max home value was $360,000. Here we are combining percentiles with frequency tables. I made you guys a video before and it's posted, I believe, right above the Exam 1 review. And in that review, we talked about relating these to maybe snowfall or anything that we want to cumulatively measure. And in that, it talks about how this 18% cumulative frequency doesn't just contain 18%. It contains from 0% all the way up to 18%. Then my second class covers 18% to 42%. My third class starts at 42 and goes to 58%. My fourth class starts at 58 and goes to 81. And my last class starts at 81 and goes to 100%. So the cumulative relative frequency isn't just the numbers you see on the table. It's a whole range of numbers that you have to consider. Now we want P39. That means we want the 39th percentile. So I'm going to go find 39 in one of these intervals. 39% falls between 18% and 42%. That's not a great circling job, but that's okay. That means P39 is 1. This one is a little bit different because you can see that 39 actually shows up on the table, where before we had to go find the 39. I'm not going to jump in just yet, though. I'm going to go ahead and set up those classes. And there's a reason. There's always, well, not always, but most of the time, there's a method behind my madness. Sometimes it is purely madness. So I'm going to go from 0 to 21%. That means the second class starts at 21% and goes to 39%. The third class starts at 39, and that right there is what I wanted you to see. And then we'll go from 61 to 79, and then from 79 to 100. What I wanted you to see is that 39 is not occurring in only one place. It's occurring in two different places. It's occurring for both one sibling and two siblings. And we can't have more than one percentile. So, what we do is we split it right down the middle. We average 1 and 2. We find the middle of 1 and 2. So the 39th percentile is 1.5. Now, a lot of people say, but Ms. Graham, this is siblings. If I have 1.5 siblings, the FBI and CPS are totally going to get involved. I get it. If you think too much about this being actual siblings, yes, it gets a little weird. Realize that the percentile is not necessarily talking about actual people. The percentile is a dividing line. It separates, in this case, the lower 39% of data from the upper 61%. So we're not talking about actual people. We're talking about a dividing line. We're talking about a yard line on the football field that separates the first 25 yards from the last 75 yards. So we're not talking about people. It's simply a spot to divide the data into two different pieces. A lot of people missed the mid-range question, and I'm really not sure why. You do have this formula on your formula chart. You also have it in the notes that you are allowed to use. And that formula says that the mid-range is the average of the max value and the minimum value. So we need to go find the max value and the minimum value. It looks like our maximum value is 133.5. Our minimum value unless I'm not as caffeinated as I thought, is 97.7. Now, I'm definitely not caffeinated enough to do that one in my head, so I'm going over here to Desmos. This is one of the things I really like about Desmos. I accidentally typed 97.9 instead of 97.7. In other calculators, you would have to clear it all out and do it all over again. But in Desmos, when you make a mistake, click next to where your mistake is and push the backspace button and just fix your mistake. It's a beautiful thing. The mid-range for this data set is 115.6. Okay, when it comes to box plots and 5-number summaries, I think a lot of you are overthinking things, tremendously overthinking things. All you have to do is match up the numbers and the lines. That's it. I don't know why that one turned into a rectangle. There we go. So my minimum value is 10. Q1 is 16. The median is 17. Q3 is 19. Max is 20. Don't change the order. Don't put new numbers in there. Match the numbers that have lines with them and put them in the box. Calculating the 70th percentile. This was intentionally put on this part of the test so that you would have to use your formulas over StatCrunch. But you had the formula in your notes. You had example problems in your notes. And you had the formula on the exam 1 handout that was available to you. We want the 70th percentile. This tells us we want P70. That implies that our K value is 70. We have 19 data values, so that's our N. And the formula we need to find the 70th percentile is I equals K over 100 times N plus 1. Now, please, please, please keep in mind that I is a locator. It's like a seat number at a concert. It is super easy to plug in K and N and do the math and think, sweet, I'm done. But you're not. That just tells you which number or which seat to go pull the person out of. We're going to plug in what we've got. We have a 70 for K. 19 is N plus 1. I'm going to go over here to Desmos again. When you're plugging things into Desmos, do yourself a favor and plug it in all at once. And what I mean by that is I will have students who will do maybe 19 plus 1, and then they'll go write it down. And then they'll do 70 divided by 100, and then they'll go write that down. But when they write it down, maybe they write down an 8 instead of the 0.7. And even though their calculation was correct, they miscopied that number and things went south. When you're plugging things into StatCrunch and it is an expression like this, you reduce your chances for error if you plug it in all at once. So we want to go look for seat number 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Seat 14. That means the 70th percentile. The data value that divides our data list into the lower 70%. So this is the lower 70%. And this is the upper 30%, is 21.7. Now this one I cheated on a little bit to save some time. I went ahead and put all of the numbers in order. Ms. Graham, why did you cross out the numbers on the chart? Because I was keeping track of the ones I've already used. And I'm hoping that those of you who missed this question missed it because you forgot to put them in order first. I'm going to do this the old-fashioned way, and I'm going to take one from the front and one from the back until I can't anymore. And I'm left with a middle number of 70. So this is the median. If you want to relate it to quartiles, this is Q2. For this misleading graph question, there were a couple of things that I decided to accept. One of the things that's easiest to do on these is to go through the answer choices and do it by process of elimination. So my first possibility says the x-axis is not scaled correctly. Meaning, when they talk about it being scaled correctly, they mean maybe we jump 2 months in one spot and only 1 month in other spots. So let's go see if they change anything up on us. You start at January, February, March, April, May. Nope, everything looks good. Well, Ms. Graham, what would it look like if that was the one we were supposed to pick? Well, maybe there was another one out here. Then all of a sudden, jump to August. We're increasing by 1 month each time, but then all of a sudden we make a big jump. That's what it would look like if the x-axis were not scaled correctly. Was not scaled correctly. I'm going to skip over the none. I'm only going to use that as a last resort. This one says the y-axis is not scaled correctly. Okay, let's go take a look. 0 to 100 is plus 100. Okay. Oh.
What?
100 to 150 is only a jump of 50. 150 to 200 is 50. 200 to 250 is 50. 250 to 300 is 50. So they were consistent on the top four. They were not consistent on that first jump. This could definitely be misleading if you are not paying attention to the scale. So I am going to put a little check mark right here, but I'm going to see if there's a better choice. I'm going to skip the outputs one for now. I'm going to go down to the number of toys sold after May is not known. So, have a brief pause for the child with allergies. That is an accurate statement. We do not know how many toys were sold after May, but that is simply information we don't know. It's not like the information has been distorted or left out or mislabeled. So not knowing that information
Is good.
doesn't really change the way we read what's already presented. So I think there's a better answer. When we found a good one, so we'll take off the none of these. Now, the most frequently picked wrong answer was the changes in the outputs are not proportional. And I thought about the language in this question because there were a lot of people who picked it. And then it dawned on me that in algebra, outputs are frequently used to describe the y values. Well, that's that vertical axis we were talking about in the answer choice above that one. If they're not proportional, well, that means if I change 1 month on the January, you can't see that because it's blue on a blue background. If I change 1 month for January, my output was 100 on my scale. If I change another month, it only went up 50. So that y increase is not proportional to the x increase. So if you picked the changes in outputs are not proportional, I did give you credit for it, and that's the reasoning why. The official correct answer was the y-axis is not scaled correctly. If you picked the proportional one, I could see where that maybe came into play. If you got lucky because you picked that one, don't tell anybody. I'm just kidding. I don't care who you tell. Okay. This histogram question was potentially the most overthought question on the entire exam. When you are looking at class width, that is the beginning of the first class and the beginning of the second class, and you subtract them. That's it. Well, Ms. Graham, what if I don't like 5 and 1? What if I like 21 and 7 better? Okay. From the beginning of one class to the beginning of the next class, It's still 4. It doesn't matter which classes you pick, as long as they're consecutive. Sample size. I got some weird stuff for sample size. All you have to do for sample size is add up the number of people or the number of objects, the number of data points in each class. So this first class is halfway between 8 and 10. Halfway between 8 and 10 is 9. The second class has 5 data points. The third class has 4 data points. The fourth class has 10. The second class has 3. The last class has 8. And then I go add them up. Again, I am not going to be a hero. It is too early for mental math, even of the most basic kind. So I have a total sample size of 39. So I find the number of data points in each class, add them up. Another version of the stem and leaf plot that may have showed up on your test. A lot of these questions were in a group, and it may be the test maker, the generator, was told to choose one from a group of 3. And so if some of these are a little different from the ones you saw in your test, that's why. So you have another stem and leaf plot. We want the minimum value, so the smallest value, but don't stop reading, keep reading, in the last class. So that means we're looking at the 7 row. So my stem is going to be 7. In that class, I have a 73 and a 76 and a 79. So I pull out the smallest one. This last one is another version of that frequency distribution table that happened earlier in these problems. This time we want the upper class boundary for the last class. I'm going to change that because we already did one for the first class where we would have backed this up to 50 to 59 and found the middle. Upper class boundary is the same idea. We add another row and find the middle. I'm going to do the third class. So I have the first class, the second class, and the third class. So the row I'm interested in is this one. We want the upper class boundary. So I'm looking for the spot that separates 89 from 90. Well, halfway between 89 and 90 is 89.5. So that would be the upper class boundary for the third class. If we wanted the lower class boundary for the third class, we'd look between 79 and 80. So that's how those work. Go through these, see if it helps. Look at your individual exams. They should be opened up soon. If you have specific questions from your exam that you would like answered, The message instructor feature will be turned on, and you are more than welcome to send me questions about your specific exam. If these sort of general questions didn't quite do the trick for you.